The other type of data that can be used for representing spatial information is the raster data. So here they're used to represent information that's very regular in space. So this is information that can be represented with the grid, with a matrix, with pixels, like an image, for example. So these are some examples and details on how raster type of data works like. So this is the identification of each one of the cells in this raster. So let's say that in a matrix, I have the rows and the columns, and I have an identification for each one of the cells. And in each cell or box, I could have values. So these are the examples of the different values. This in R represents a not available value, something that does not exist, that I do not know. And this would be the colored values. So this shows us how the information of the number that's in this format can be used to visualize that information. So the greens represent the highest numbers and the red ones are the lowest numbers. And what's white or transparent are the unavailable pieces of information. So this is a very general type of format to see what type of raster data I have. This does not have the concept of lines or polygons, but it's a simpler way of doing things. It's got pixels, and the pixels are organized in this way. This is another type of raster with values between 1 and 9, with color codes representing each one of the numbers. And another way that I can look for a specific element in this raster, not only by coordinates, geographical coordinates like latitude and longitude, I can also do it with matrix coordinates. So the raster is interpreted with a matrix, and you can use the sequential ID, or this way that will be on rows and on columns. So this is the row 4, column 3. So if I have to change a value or extract a value, it can be done with the IDs of the cell and the matrix. This is another way that software works internally. Numbers do not have to be full numbers. They can be categories or continuous numbers. For example, this would be numbers with decimals, and I can apply a classification of the data and generate category data, and some parts were left out of the category. So these are the same numbers, the same data, but represented in a different way by a classification, which is a very common task that we do with raster data. Another important point is that we are seeing one matrix, but normally many of the raster layers are going to have more than one layer. And these layers, they can, for example, be type RGB, red, green, blue. And these are commonly used to create an image that's very similar to what we can see with our bare eyes. So this is how the data is organized, how the digital pictures are organized, and everything regarding pictures are using these RGBs. And it could have more layers. For example, satellites, they have 10 to 15 different layers in different regions of the spectrum of light. All this can be captured in a different way, and there's some sensors that have more than 1,000 different bands or layers, and they can also use these layers to represent temporary information. So the layer does not necessarily has to represent a different type of color or light. This can also represent other types of variables. For example, if I'm working with soil data, I can have a raster that has a layer for organic matter, another for pH, and so on and so forth. So you can have different layers. Or you can have a layer for dates also. It's very common to use, for example, a vegetation index in EDVI, and I can have a value for each date. So every layer can also represent a date, and these are spatial layers. And in the raster data, whenever you have data like this with more than one layer, this is going to be represented like this raster stack. And right here I have the dimensions. So these are the numbers of rows and columns, and this will be the total number of cells or boxes, and then the number of layers in this raster. So in this raster, I only have one layer. This is an example that we can use afterwards also in QGIS. This would be your organic carbon in the soil, and this is the resolution. So this would be in degrees, and this resolution in meters is equivalent to 250 meters approximately. So how can we read this in R? And after reading the information in R, I can also create a plot, a very simple map, and have this distribution of the values. So these are the coordinates, the latitude, the longitude, and the values. These are the values of the organic matter in the soil. This would be another part of the Chiapas map, and you can see the higher and the lowest values and how the spatial distribution of these values look like. So the raster data is very useful for whenever you have data that covers the whole surface with pixels